There we go. All right. So 11.5, all about volume. Not limits, volume. That's pre-calc. There we go. Okay. So today we're going to focus on a particular kind of volume of cylinders and prisms only. So 11.5 volume. And then subcategory here is cylinders and prisms. Okay. So the first thing we have to remember or learn for the first time, what is a cylinder or a prism? So, are we having a quiz for this unit? No, there will not be a quiz at the end of this one. This one is just good things to know, things that could show up on things like state testing or the SAT and fun stuff like that. You'll still be getting points for the assignments, though. Yeah, a cylinder is like an extended circle. I like it, Caleb. Yeah, it's like if you were to take a circle and extend it either up or down. It's a good way to think of it. Or you can extend it to the side, like. And you can have, short, fat cylinders or long, skinny cylinders, like a short, fat one, like a tuna can, or a long, skinny one, like a tube or something. But anyway, these would be cylinders. And then, what's a prism? Anyone know or remember? Sounds a little bit harder to describe. I think we'll kind of go off of Caleb's definition of a cylinder here, like an extended circle. A prism is an extended polygon. So any other polygon, like a prism, you could have a triangle. Like if you've seen a Toblerone, those are triangular prisms. Or you could have a rectangle or a square that gets extended. And this is where you get to see a fun Miss Lindell trying to draw in 3D. Or you could even have something like a pentagon that gets extended. So these would all be examples of prisms. Okay, so that's what we kind of need to know first, right? And they can be, sitting on any of these faces, so they don't have to be laying down like that. They're just a little bit easier to draw when they're laying down like that, because you can kind of draw the face and then extend it. And when we're working with cylinders and prisms, the front face matches the back face. So like this front pentagon here would match the back pentagon in size and shape and everything. This front triangle would match the back triangle. This front square would match the back square. Okay. So once we know what a cylinder or a prism is, now we need to talk about how we would find the volume. And so our volume formula here. It's the same for cylinders and prisms. It's volume equals capital B times H. where capital B stands for area of the base, and H stands for height. Now you can have different little volume formulas for each of these different shapes. Like technically for a rectangular prism, you could do length times width times height. Or for a cylinder, you could do pi r squared times the height. But what that really is the same thing as this, area of the base times the height. So when we're looking at these shapes, the first thing we need to do is identify what is the base. And the base is not always on the bottom. For example, on this cylinder here, this would be the base, or this. There's two bases. But on this one, the top would be, or the bottom would be the base, either of these. It's the face that is present throughout the shape. It's the whatever face gets extended, that is your base. So this would be the base, or this, for my triangle one. This would be the base, or this, for the rectangle. That would be the base, or the back face, for the pentagon. So, and then the height is that distance between the bases. So the height of this cylinder would be this distance between the front and the back face. Or the height of this cylinder, standing up, would be something you more typically think of as a height. Or the height for this. And here's our height. Height. All right, so it's that distance between the two same faces there. Okay, so we've broken down what is a cylinder or a prism, what is our volume formula. Any questions so far? Okay. Then we are going to now find some volumes of different cylinders and prisms here. Let's do some examples. All right, so the first one we'll do will be a cylinder. Okay. We are going to find the volume of this cylinder. And we're going to attempt to draw a cylinder. And we are told that this distance is 5 centimeters. And that this distance is 12 centimeters. Okay. And that's all we really need in order to find the volume of a cylinder. So we know that volume is area of the base times the height. So now we have to start with finding the area of the base. And the base for a cylinder, in this case, is going to be pi r squared because the base is circular. All right, so we have to find the area of that circle to start with. So that would be pi times 5 squared, since 5 is the radius, which would be 25 pi. Now you can leave this as a in exact form like this, or you can type it into the calculator, 25 times pi, and we get approximately 78.54. All right, so there's the base. And then the height. What's the height going to be for this cylinder? What do we think? What's the distance between the top and the bottom there? 12. All right, so we now have our area of the base, we have our height, so the volume is then going to be 78.54 times 12. And we get 942.48. And that would be for our units on something that it has volume. So with area, we had our units were squared, right? For volume, our units are going to be cubed. If you think about it, a cube has, volume. We also, if we got square centimeters from the area here, and then we're multiplying by centimeters again, that gives us centimeters cubed. So anytime you're dealing with volume, your units are going to be cubic units. Okay, any questions from the first one? Any numbers we're not sure where they came from? Steps we're not sure how they happen? Okay. Then let's do another with a different type of prism this time. Okay, so this time we're going to do a rectangular prism. And pretend that that looks like a rectangle. Oh goodness, all right. Well, rectangular prisms, we're struggling here. All right, so we are told that this side length is 10 inches, this side length is 4 inches, and this side length is 3 inches. Okay. So for this kind, volume is still area of the base times the height, but this time our base is a rectangle. This particular rectangle here. The nice thing on most volume problems, they just give you all of the numbers. But anyways, so the area of the base for a rectangle is base times height, or you might have also seen it as length times width. Either way, we're just taking for this face right here 3 times 4, which is 12. And then our height is just the other number that's involved. It's the distance from the front to the back here, 10. And so then our volume is just going to be 12 times 10, which is 120. And then it's cubic inches. That's probably the easiest kind, because really all we had to do was multiply these 3 numbers together. You might also see for a rectangular prism, just do length times width times height. That also works. Basically multiply these 3 numbers and you're good to go. Any questions on the second one? Any numbers we're not sure where they came from? Steps we're not sure why they happen or how they happen? Okay. Then last example before you guys get to try some on your own. Triangular prism. Okay. So this one is going to look a bit more like a Toblerone. And we are told that this distance here is 3 centimeters. This distance is 8 centimeters, and this distance is 12 centimeters. All right. And since this is this one has a base that is a triangle, our volume formula though is still the same, area of the base times the height, but this time we have a triangle base. So this particular triangle here. All right. So who can remember what's our formula for the area of a triangle? I know it's been a little bit since break and all. Formula for area of a triangle. Who's awake out there? Base times height divided by 2. So big B is going to be small b times h divided by 2. And so then our base and height here for our triangle, 8 and 3, which gives us 12. And then what's the height of this whole cylinder going to be? Or not cylinder, the prism going to be? This is a part that sometimes people get confused by, because we also deal with a height in the area of the base formula. But this is going to be a different height. What's that height going to be? Somebody knew. Don't make me cold call somebody. What do we think? What's the height for this? What's the, or in this case, it might be better to term it the length. What's the distance between the two faces here? Yeah, 12, exactly. Thank you, guys. We are awake. The height is going to be 12. It's this distance here between our two faces that look the same. So between these two faces, we have a distance of 12. Awesome. So then our volume is going to be area of the base times the height. So it's 12 times 12, which is 144 cubic centimeters. All right. Any questions with the third one? Any numbers we're not sure where they came from? Steps we're not sure how they happen or anything like that? Okay. Then it's time for you guys to try a couple here. First one. All right, we've got this box. We'll say this side length is 3 feet, 2 feet, 5 feet. It's a large box. And these corners are right angles. It's a rectangular box. Go ahead and find the volume there. And then here we'll do a cylinder. With a 2-inch radius. And then this side is 16 inches. go ahead and find the volume for both of those. You can use the examples that you've got already, examples 1, 2, and 3. When you think you have them, type "got it" in the chat, and I'll give us little hints along the way. All right, Caleb's got it. Speedy. All right, for both of these, volume is area of the base times the height. So if you started with that, that's a good place to begin. And then identifying a base. So on this one, we got a rectangle. On this one, we got a circle. So on this one, if you started with the rectangle being base times height, or the circle over here being pi r squared, that's a good place to begin. And then for the overall height here, we got the other dimension, 5. So if you got 6 times 5 or 30 cubic feet for the first one, you are on the right track. Another way you could have done the first one is just gone 3 times 2 times 5. It's the same exact thing that we did by finding the base first and then multiplying by the height. And then on the circle, if you chose the radius to be 2, this measurement right here, you're on the right track. And then approximately 12.57 there would be the area of that circle. Or you could do 12.566 if you want to keep an extra decimal place just to have a little bit more accuracy. And then the overall height here, if you chose 16 for that, you're on the right track. And then for the volume, we take that area of the base that we found, 12.57, and multiply it by that height of 16. All right, so for that, we should get about 201.12. And that would be cubic inches. So if that is what you got, you are doing well. If you got something else, maybe see around here, did we put in the correct value for the radius? Did we square it correctly, all of that? Did we pick the right number for the height? Did we maybe type something into the calculator wrong? Okay. So now I want to know, in the poll section, on a scale of 1 to 5, how are we feeling about finding volumes of cylinders or prisms? 1 being I could use a lot more examples and help. 5 being this is super easy for me. What are we feeling? 3, maybe I could just use some more practice. I'd love everybody to vote. All right, got about 30 seconds. All right, if you can't vote in the poll, go ahead and put it in the chat like you did, Ala. Thank you. For whatever reason poll isn't working, feel free to put it in the chat instead. All right, 10 more seconds. All right. Looks like we're at mostly 3s and 5s. So I think we're ready to practice on our own. But if you would like to stick around and get more examples with me, once I post the assignment, you can absolutely do that. I'd be happy to go over as many problems as you would like. But we'll get started over here. I'm going to post the assignment and we'll take a look at it together. It is just one IXL section. Going pretty light on the assignments this week because it is the last week of the quarter and we got a lot going on. Okay, so it is IXL T5 to a smart score of 80. So here's our IXL section. Volumes of prisms and cylinders. It starts off with a real simple one. A 1 by 1 by 1 cube. So you just go 1 times 1 times 1, which is 1. And then we go to a volume of a cylinder. Notice it says to use 3.14 instead of pi. So if you're using a calculator with a pi button, for this IXL section only, make sure you use the approximation 3.14 instead. So like, for example, on this one, pi r squared would be 3.14 times 2 squared, since the radius is 2. And then multiply that by the height of 4. So for this one, we should get 50.24. So make sure you use that approximation where pi is 3.14. Okay. So at this point, if you have questions or would like to go over any more examples with me, feel free to stick around. Or if you have questions about anything grade-wise either, feel free to stick around. Otherwise, you are good to go and enjoy the rest of your day. Work on the assignment and have a good one.